So we understand that a wire with current can produce a magnetic field. And we took up a particular scenario wherein we took a straight wire and we saw at a given point how much magnetic strength it can have. But we didn't discuss about direction per se. As a whole, a given wire, what will be the net magnetic field? What is the pattern? So that I'll show it with the following discussion. Now we're looking at the directional aspect of a straight wire conductor. So the basic structure is that it's concentric. Okay, the word concentric is pretty important over here. Actually, it is the one. So what we are looking at here is we have a wire, current is flowing that way. So with this as a center, you can take up any point, right? You can take up any point and draw circle with that as a center. So this will be the magnetic field pattern. We're looking at the pattern a bit. So I have this for you guys over here. So let me start off. We can see, notice a small magnet over there, and notice that the current per se is 0, so there's no deflection. So once with deflection, right? See, can you see that there's a deflection? So if we keep moving that, right? If I keep moving that, which I'll keep doing, can you see that? Let me pause it over here. So here it is pointing somewhere towards us, and there it's pointing exactly towards us. There it's pointing to the left, almost to the left. And here it's pointing somewhere over there. Oh, sorry, you can't see somewhere over there. You can't see my mouse per se. So it's pointing to the right. And I'm using the bigger compass, so you can see it's clear in this, right? Okay. Right, guys. So what's happening? You can see that it's kind of circular, right? The whole thing is circular. Of course, I need to have a stronger set of wire and a lot of current going through, and we'll get a better deflection and all of that. Now the current is small and it's pretty far away. So whatever deflection we're seeing, it's by a negligible magnetic field. So it's circular. But the north is pointing to a particular direction. So we need to talk about the directional aspect. This was a pattern, that's all. We're not yet spoken about the direction. The direction is given by right hand rule. So what does it state? If you hold your right hand in such a way that the thumb is pointing in the direction of the current, in direction of current, then you have to hold the wire in between your hand, that is wherever you want. For example, over here the magnetic field will be pointing in this way. Over there, like at the other end of the wire, I guess, is pointing that way, and in front it will be pointing this way. Basically it is circular. In this case it is anti-clockwise when you look at it from the top. Of course it will be so here as well, right? So if you point your right hand thumb in the direction of the current, your curled fingers will indicate the direction of the magnetic field line. As simple as that. So basically here it is magnetic field line out, here it is in. Okay, this notation you guys have to get familiar with. This is out and this is in. Okay guys, next we have the graph for magnetic field versus distance graph. Magnetic field by a straight wire. So this is your B and that's your distance. So how does it vary? It will vary this way. Okay, why? Can you tell why? Because B is inversely proportional to a to the power of 1. So because of that reason, as in when we go far away, the strength decreases. Common sense. So that's all. You need to know this as well. And yes, this is going to be used everywhere. It's a very simple thing. So be very clear with this.